See how stupid I am today. This is Combining Function Types and Context, Unit 4, Lesson 8. This is a short one at least. I'm thankful for that. Example 1. Dante travels from home to his office. First, he walks to his bus stop and waits for 3 minutes before it arrives. After Dante's stop, the bus heads toward the office and travels half a mile for 4 minutes. Then it stops at another bus stop for half a minute. There is one stop left to make, which is 2 miles from Dante's home. It takes the bus an additional 5 minutes to get there. Create a graph of various function types to represent Dante's distance from home over time, starting with his time at the bus stop near his home. What type of function would you use to represent Dante's time? Now, I made this yesterday, this slideshow, and I don't remember there being anything at the end about you having to create a graph like this without a formula, so don't stress about that too much. What it wants to know at this point is what type of function would you use to represent Dante's wait time, and that's a constant function. Now, it didn't teach you any of this, it just throws you in and expects you to know this. So if you didn't know that, don't worry too much. And there is a little slide later on that writes down all of this stuff. But if you're just waiting, if you have a flat line where you're not doing anything, because on the graph, if you're waiting, time is passing, but you're not going anywhere, that's going to be a constant function. Okay? So we have the same word problem of him with the bus. So what type of function would you use to represent bus travel time? So instead of being just a straight line where time is passing but he's not moving anywhere, this time his travel time is going to be like a slope, like something like that. And that is a linear function. Okay. So here's like the graph that they created. This is waiting time. This is waiting time. These orange lines. Oh, what do the horizontal solid orange lines mean? These are waiting times. Okay, so they show the times when Dante is not moving. He's waiting for the bus, or the bus has stopped to pick up more people. And that makes sense because time is the independent variable. It passes no matter what Dante's doing. He could be overthrowing the world in his evil dominion, and time is still going to pass. Okay? So, but he's not going further away. He's not traveling any distance further from his home. So it's just a flat line. Okay, so this is a constant. Okay, constant because it's just flat. We're back to our little graph again, and it says, what do the increasing linear functions represent? So these blue sections, what do they represent? That Dante is, no, that's wrong. The blue sections represent that Dante's moving, that he's moving farther away from his home or closer to the library or wherever it is he's going. Because office, he's going to the office. I don't really care, Dante. The bus is moving when the line is blue. You can see that because it's increasing in the distance over here on the y-axis. Okay. So here's example number 2. Layla works 12 blocks from home and begins walking home. She walks 2 blocks in 1 minute. These are really small blocks, or she's hoofing it, man, and stops at a store for 5 minutes. Layla then continues her walk of 8 blocks in 4 minutes. She is eager to get home, so the last 2 blocks she walks faster and gets home in half a minute. What type of function would you use to represent the time Layla spent in the store? Okay, so so it's something like she walks for 2 blocks, and then she stops at the store, and then she continues her walk, okay? And then she walks faster, so it's a steeper slope. It's going to look something like this. This is a really lazy, sloppy line, but it wants to know what type of function you're going to use when she's in the store. Do you remember? It's a constant. Constant means flat, okay? Now, what type of function would you use to represent her walk? These are the slope lines, okay, when she's actually making progress on the y-axis. Do you remember what kind of function she's using there? That's linear, okay? So anything that has a slope is linear, and it doesn't have to be positive. It could be negative. It's still linear, okay? So here's the graph that they did. Oh, they chose negative, okay, because I guess she's going home. Whatever, you do you, boo. So y is the dashed green line. That's this little section right here, okay? Why is it steeper than the solid orange lines? Well, if you read this, it's because she walked faster when she was almost home. She was done with it. She wanted to get home. Okay, so the slope increased right here. It's hard to tell on this graph, but it did increase. She did go faster. Why do the solid orange lines have the same steepness? Why does this line and this line have the same slope? Because she was walking at the same pace. That says up here she walked 2 blocks in 1 minute, and then she walked 8 blocks in 4 minutes. So she's spending 30 seconds on each block. Okay. What was Layla doing during the horizontal dotted blue line? What was she doing right here? Let's see. She stops at a store for 5 minutes. Okay. She was not moving closer to home because she was at the store. Da, 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 da. Here's example number 3. A diver is standing on a diving board that is 15 feet above the water, waiting to take her dive. She waits there for 5 seconds before jumping and diving into the water. The dive takes 1.4 seconds before she breaks the water. Create a graph that could demonstrate the scenario. Okay, so the y-intercept is going to be up here at 15 because she's 15 feet above the water. We know that much. She's going to stand here for 5 seconds, and then she's going to dive, which is going to take 1.4 seconds. And I guess that'll take a little bit of time. It'll be a little bit of a slope. And then she'll hit the water, okay? So when she's waiting, what type of function is that? Do you remember? Constant, because constant is just flat. Okay, well, that wasn't very flat. That's a little better. Okay, what type of function represents the dive when she's going down? Okay. They say that's a quadratic, I guess, because when she's diving, it's going to go something like this. Okay. I would never know that. I would have said linear, but whatever. You can see, yep, they did. They did a whoop-a-doop-a-doop jump. So here's what the graph would look like. And when did the diver jump? Okay, there's 2 places you can find this. She waited there for 5 seconds. You can also come here on the chart, and you can see here's where she jumped, and if you follow it down, it's at 5 seconds. There's 2 places you can find that. Okay. The diver jumped at 5 seconds. What was the maximum height the diver reached? She went up. So if we come here and follow it across, we can see that she jumped a little, the highest she was a little over 17 feet. Okay. The diver reached a maximum height of approximately 17.3 feet. Now, how I'm supposed to know that's 0.3? I guess I'd have to be a math book to know that. But, whatever. Here's a check-in. What type of function can represent a waiting or stopping period in a situation? If you're waiting or stopping, it's a flat line. What is that? You can do this. It's a constant function. The constant function represents a situation with 0 slope or no change in rates. This should be in your notes. What function type would represent something falling from the top of a building to the ground? Here's the top of my building, and it's going to go and hit the ground, okay? What function type would represent something like that? Honestly, I don't know. They're saying quadratic because I guess you're going to throw it and it's going to arch. Quadratic functions represent any item or situation that involves gravity. Didn't know that. Woohoo! Gold star for you. That should go in your notes. Interactive question, okay? It gives us these 4 options and then these that you have to match. So, distance from home as you drive home. So we're heading home. Is that a linear function with a negative slope, a quadratic function, a constant function, or a linear function with a positive slope? Since we're going home, I'm going to assume that's the negative one because that's what they did before. Distance from home as you walk away from home. I'm guessing that's a positive slope. Waiting for a car ride to the movie theater. We know that one. That's our constant. And throwing a ball because we're dealing with gravity. It has to be our quadratic function, which I can no longer get to. Come here, quadratic. Okay, I know that now. Gravity means quadratic, man. Okay, that's how you do that interactive question. Here is question number 1. This is your turn. He's watching you and judging you. What function types would be appropriate to represent the following scenario? Okay, so it wants types, plural. So you're going to have more than one. Joanna is heading to the city. She is leaving home and traveling 125 miles to get to her destination. If you track her distance from home and she stops one time on her way there, what types of functions can be used? Pause it, figure it out, come back. Okay. Positive linear function because she's traveling away from home, and a constant function because she stops and then she keeps traveling. As Joanna starts her trip, a positive linear function will show her distance traveled. Then she stops. The constant function will represent her travel. The final leg of her trip can be represented by a positive linear function. Okay? Shoop. Here's question number 2. Referring to the graph, What scenario could represent the solid orange line? Now, this is one of those many answer questions, so they just give an example. But what's going on if we have these solid orange sections? Pause it, figure it out, come back. Forward motion stopped on your travels. They're using travels for a specific reason, because this is time, okay? Reasons for this might include a stoplight, store errand, gas station, animals crossing the road, etc. I say that you threw a ball, but you're Harry Potter, and so you made it stay in the air, and then it fell, and then you made it stay in the air, and then it fell. Yeah. Okay, practice question number 1. This is at the end of the lesson, so just write your answer down so you can enter it when you get there. You are driving at a pace of 65 miles per hour toward a destination. Select the number of the function that could represent this scenario. Is it a linear function, a constant function, or a quadratic function? Speed round. Boo, 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 boo. It's a linear function. Okay, because you're just driving at a constant rate of speed the whole time. All right, here's practice question number 2. A car stops at a stoplight for 30 seconds. Select the number of the function that could represent this scenario. Linear, constant, or quadratic? Speed round. Boo, 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 boo. It's a constant function because you're stopped. Okay. Quick check question number 1. I will not give you the answers because you get graded on the quick check, but I will tell you how to find the answer. An item is being lifted by an elevator at a constant speed to a height of 10 feet. It goes up. The item does not move for 5 seconds and then catapults off the 10-foot platform and back to the ground. You're fired. Whatever you did to this thing, you're fired, okay? It actually would have a slope at the beginning like that, just so you know. Compare the height of the item to the time passed in seconds. Determine the correct types of functions that describes the scenario in the correct order. Functions means you have more than one. So they want the correct order. So first you have this type of function with a slope, then you have the flat function, and then you have the gravity function, which does the whoop-de-doo. Okay? You can do this. Type 1, type 2, type 3. Okay? Get them in the correct order. Here's quick check question number 2. What scenario can be represented by the line labeled number 2 in the graph? Okay? What's happening right here? What is this? Is there an object falling from a tall building? Are you walking back toward home at a constant speed? Are you stopping for an animal to cross the road? Or are you speeding up to reach top speed? You can do this. Here's quick check question number 3. What scenario could represent the pieces of the function types in the graph? So you want this in the right order. What's happening? An athlete goes on a run from home and then comes back home. Well, obviously that's going to be wrong because there's 3 pieces and that only gives us 2 things. So goodbye, idiot. An ultimate frisbee player throws a frisbee and scores a point. Well, I guess all of these only have 2, so maybe that one is correct. I won't eliminate for you. A diver climbs to the diving board to jump. A train ride at the fair has 1 stop. All right, you can do this. I believe in you. Only one of these is logical. Adding and subtracting functions. And this is the second half of our lesson, and then it's over. I actually don't hate this lesson. Okay, so we have these 2 formulas right here. This is the first one. This is the second one. Okay, this one is adding. This one is subtracting. Do you feel smart? I do. Okay, when adding f of x and g of x to create a new function, the name of the new function is f plus g of x, where f plus g of x is equal to f of x plus g of x. For the given functions f of x and g of x, calculate f plus g of x and its domain. Then calculate f plus g of negative 1. So we're going to do 2 separate problems here. Note that the domain for each of these functions is the set of all real numbers. We'll get into the domain thing in a minute. It's the only part of this that might be tricky. Okay? So if we're doing f plus g, we're going to take f, which is x, plus 2. Okay, I'm going to put it in parentheses just so that you can more easily see what's going on. And we're going to add g, which is x squared minus 4. Now, if you want the left side of this because you're used to seeing it, it makes you feel better, it's f plus g of x equals. Okay, I never bother with the left-hand side because it's just more writing and more effort. So we need to combine like terms. We always put the highest power first, so x squared is going to go first. Okay, I'm going to cross it out because we know we used it. Then we have our x, and it's a positive, so we have positive x. And then we can combine these two terms. Negative 4 and positive 2 is negative 2. So this is our final formula. Okay, we have f plus g, and they put this in parentheses because they don't want you to think it's just g of x. It's f plus g of x. Okay, f plus g of x is equal to x squared plus x minus 2. Okay, and I believe I have that on the next slide. X squared plus gx minus 2. I didn't put it there. I'm going to go see if I got my slide orders mixed up. Okay, I just must not have put it. Anyway, this is the formula. So now they want us to solve it for f of g is equal to negative 1. So what we're going to do is we're going to put negative 1 in for each of these x's. So in parentheses, because the negative is stuck to it, we have negative 1 squared plus negative 1 minus 2. Negative 1 times negative 1 becomes positive 1. Positive and a negative, negative wins, and negative 2. 1 minus 1 is 0, minus 2 is negative 2. So the answer to this one is negative 2, which you can see right here. Okay. When subtracting g of x from f of x to create a new function, the name of the new function is f minus g of x, where f minus g of x is equal to f of x minus g of x. For the given function f of x and g of x, calculate f minus g of x and its domain, then evaluate f minus g of negative 1. So first of all, we're going to go f minus g of x to find our new formula, okay, is equal to our f problem, which is x plus 2, minus our g problem, which is x squared minus 4. Now, the first thing that you need to do, this is the same as having a negative 1 right here, so you need to distribute it out like you're multiplying negative 1 by each of these. The easiest way to do that is to just flip the signs for everything. So we have x plus 2, and then we're going to make this a plus, okay, negative x squared plus, I'm running out of room, 4. And there's my parenthesis. Okay, now we're going to combine like terms. Our highest power is x squared, so we have negative x squared. Then we have a positive x, and then we have positive 2 and positive 4, which is going to give us positive 6. So this is our new formula. Now we need to figure it out when f minus g is of negative 1. So negative 1 for all this stuff. So negative 1 squared plus negative 1 plus 6. Have you noticed how much better I've gotten at writing with my mouse? I'm quite proud of myself. So this negative stays. Negative 1 and negative 1 becomes positive 1. Plus and minus means negative wins. Plus 6. Negative 1 and negative 1 is negative 2. Plus 6 gives us positive 4. So f minus g of negative 1 is equal to 4, which we see right here. Okay. When subtracting g of x from f of x to create a new function, oh, we need the domain. Okay. So the domain, we haven't done this in a while. The domain for this problem is, we have to go back and look at all of our steps here, because we have to make sure that, oh, for this one it's not hard because it's not division. Never mind. It's all real numbers. Just, yeah, we're just going to roll with that because this includes all real numbers and this includes all real numbers. Okay, whatever. Just accept it because it doesn't matter yet. Okay, now we're going to do multiplying and dividing functions. This is where it gets a little confusing on the domain. So we have our same two formulas that we had before. When multiplying f of x and g of x to create a new function, the name of the new function is f times g of x is equal to f of x times g of x. For the given functions f of x and g of x, calculate f times g of x and its domain, then evaluate f times g of negative 1. So if we have f times g of x. That's going to give us our f problem, which is x plus 2. And we're going to multiply that by g of x, which is x squared minus 4. Now remember, we have to distribute it out. So this gets multiplied by this and by this. And this gets multiplied by this and by this. Everybody wants attention, okay? So x times x squared is going to give us x cubed, okay? And x times negative 4 is going to give us negative 4x. 2 times x squared is going to give us plus 2x squared. And 2 times negative 4 is going to give us negative 8. Now we just need to put this in the standard form. So power, highest power first. X third, x cubed plus 2x squared minus 4x minus 8. Okay, so this is our new formula. And now they want us to solve for f times g of negative 1. So each x is going to get replaced with negative 1. Negative 1 cubed plus 2 times negative 1 squared minus 4 times negative 1 minus 8. PEMDAS always matters. So we're going to do exponents first. Negative 1 times negative 1 is positive 1 times negative 1 becomes negative 1. Okay. Negative 1 times negative 1 is positive 1 times 2 is 2. Negative 4 times negative 1 is positive 4 minus 8. Negative 1 plus 2 is negative 1. Wait, is positive 1, sorry. Positive 1. Positive 4 and negative 8 is negative 4. So our final answer here is negative 3. Okay. And negative 3, and the domain is all real numbers. The only time that you get sticky domains, at least in this lesson, is when you're dividing. So otherwise, just assume it's all real numbers. Okay? Now, when dividing f of x by g of x to create a new function, the name of the new function is f over g of x, where f over g of x is equal to f of x divided by g of x. For the given functions, f of x and g of x, calculate f over g of x and its domain, then evaluate f over g of x minus 1. So we're going to do the same steps we've been doing before. You would set it up. This gets into the domain stuff. So you would set it up as x plus 2 divided by x squared minus 4. Okay. And that whole problem, I didn't write down the formula because I was confused at this point, so I apologize. So I'm not sure I know how to solve this because we want to get a standard form like this. So over here we have f of g, f over g of x equals this nonsense, okay? So I could multiply both sides and get this out from being a fraction, but it's just gonna, maybe you just leave it in this form. Maybe that's all you do. I'm not entirely sure. And then if we're gonna do it for negative 1, let's plug in negative 1 to all of our things. So we have negative 1 plus 2, this goes in parentheses, divided by negative 1 squared minus 4. Let's try this. So negative 1 plus 2 gives us a positive 1. Negative 1 times negative 1 is a positive 1. Minus 4 is a negative 3. Okay, that's all you do. You just leave it in this form because here's our answer for the negative 1. Okay, so from the final step of f divided by g of x, you might suppose that the domain is all real numbers except x equals 2. Why they think x equals 2 is not included, I'm guessing is because of this 2. I don't really remember this domain crap. But they say that produces a 0 in the denominator. Oh, okay, I can see why. Because if x is 2, then 2 squared would be 4, and 4 minus 4 would be 0. Okay, so they're saying that can't work, because if you have a 0 in the denominator, it's an undefined number, and that's not a real thing. Okay, so you can't have 0 in the denominator. So what you have to do is you have to look at this step of the problem and make sure that there are no x values here that are going to create a 0, because those ones have to be excluded from the domain. So we know that 2 has to be excluded from the domain, because 2 squared minus 4 will give us 0. Okay, that one checks out. However, you have to look at each step of the simplification and exclude any values of x that result in a function being undefined. Since one step in the simplification also has the term x divided by 2, where do we have that? X divided by 2. I'm not sure. In the denominator, the value of x equals negative 2 must also be excluded. Well, that makes sense, because if you have negative 2 squared, you still get positive 4. So anyway, I don't know why they're talking about all of that, but negative 2 has to be included as well. Okay, so the domain for this one is all real numbers except 2 and negative 2. All you need to remember from this takeaway is check your steps. If you have more than one step, check all of the steps and make sure there are no numbers that are going to give you 0 in the denominator. If they give you 0, they have to be excluded from the domain. Okay, here's example 1. From 2000 to 2020, the number in thousands of females of a particular variety of insect can be modeled by the function blah. The number in thousands of males of the same variety of insect can be modeled by the function blah. For both functions, t is the number of years since 2000. So they want us to find f plus m of t, state the domain, and explain what it represents. Okay, we're going to do this together, don't panic. So the first thing is to find f plus m of t. So in order to do that, we're going to take the f problem, which is negative 0.008 t squared plus 0.11 t plus 3.6, and we're going to add m, which is 0.0001 t cubed minus 0.007 t squared plus, I'm going to run out of room, 0.12 t plus 3.5. Okay. Now we're just going to add all these together. So let's do it in the correct order. We're going to start with our highest value, which is t cubed. So we have 0.0001. I'm going to make my t a little bit curvy so we can tell them apart. T cubed. Chunk. Now we need to do the t squared. We have negative 0.008 and negative 0.007. So that's going to be negative 0.015 t squared. Let's get rid of these ones. Then we have just plain t, which is, we have 11 and 12, so it's going to be 0.23 t, tonk, tonk, and then we have 3.5 and 3.6, so it's going to be 7.1. Okay, that's our final formula right there. Okay. Now we need to figure out the domain. Because we're not dealing with division, it's just going to be all real numbers. As long as time is between 0 and 20, because we're dealing with a 20-year time period. Okay. So for the y values for population, it's going to be like both positive and negative, but for the x values, we're limited to that 20 years. Okay. Next, explain what f plus m represents, and it's the total population. It's both the females and the males for that 20-year period. Okay, here's example 2. A rectangular window has length x feet and width 3x feet. Write each dimension as a function and describe a real-world scenario created by multiplying the functions. Include any restrictions to domains. Now, I'm a very visual learner, so the very first thing I would do is draw my rectangle. And it would say, I'm going to call this the length because it's shorter and it's going to be x. And the width is going to be 3x, just because I need to see that. You may not need to do that, but that's what I need in my head, okay? Let f of x equal x, so this is the length, okay? And g of x equal 3, oh, it's 3 minus x, I'm sorry, which is the width, okay? Because the function describes the length and width of a rectangular window, the range of each function must be positive. You can't have a negative sized window. That doesn't work. That's like a black hole. Therefore, the domain of both functions must be the set of all real numbers x, such that x is between 0 and 3. The product of the functions is the function f times g of x, because that's how you find area, okay? Calculate the function by multiplying fx and g of x. So all you would do is you would take your formula for f of x, which is x, and multiply it by g of x, which is 3 minus x. You have to remember to distribute everything, so this becomes 3x minus x squared. I have to write it in the right order, so it's really x squared negative x squared plus 3x. Okay, that's going to be our new formula. You can see that right there. The domain of f times g of x is the same as the domains of f of x and g of x. So if you figured it out for the two separate ones, the domain does not change. It's all a set of real numbers as long as x is between 0 and 3, because we're dealing with this formula, okay? Because the function f times g of x is the product of the length and the width of a rectangular window, the function represents the area of the window and has units of feet squared. The restricted domain guarantees that the area is positive. You can't have the black hole window, all right? Check in. What restrictions must be made to the domains of f plus g of x, f minus g of x, f times g of x, and f divided by g of x? The domains of each of these functions must be restricted to domains common to both f of x and g of x. So if you can figure out what the domains are for each of them individually, you know what the domains are for them together. In addition, if any number in this common domain results in an undefined function, which means it's over 0, at any point after the function operation is performed, it must be excluded. So with this one, if you end up with a 0 on the bottom of the fraction, wrong number, can't be in there. All right, don't stress that it's not this hard at the end. Question number 1, your turn. Given f of x is equal to x squared plus 3x minus 10 and g of x is equal to x minus 2, find each of the following combined functions as well as any restrictions to their domains. So pause it, figure it out, come back. Okay, for f plus g of x, you're going to take your f problem and go x squared plus 3x minus 10, and you're going to add g of x, which is x minus 2, and that's going to give you x squared, that one's gone, 3x and x is 4x, that's gone, negative 10 and negative 2 is negative 12, pa-chonk. And that is going to be all real numbers, right? Okay, let's do the next one. Chunk, chunk, chunk. Okay, f minus g of x. So we have x squared plus 3x minus 10. Now remember, because we're subtracting this one, all of the signs are going to get flipped. So I'm going to go ahead and put my plus and then change all these signs. So it becomes a negative x and a positive 2. Okay, now we can just add them together. X squared goes first. Chunk. 3x minus x becomes 2x. Chunk, chunk. Negative 10 positive 2 becomes negative 8. And there's your formula for the second one. And it will be all real numbers. Let's do the next one. We have f x squared plus 3x minus 10 times x minus 2. we're multiplying these, you have to distribute everything out. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. X squared times x is x cubed. Oh no, I already did that. I'm sorry. We're moving on to the 3x now. 3x times x is plus 3x squared. 3x times negative 2 is negative 6x. And then we have negative 10 times x is negative 10x. And negative 10 times negative 2 is positive 20. Now we need to combine like terms. We still have x cubed. Negative 2x squared and positive 3x squared becomes positive x squared. Oh, and I still have a minus 10x. Oh, no, these two. Negative 6x and negative 10x is negative 16x. And positive 20, there's your formula, and it will be all real numbers. And now we need to do the hard one. All right, we're doing our division one. So we have x squared plus 3x minus 10 all over x minus 2. And it's not going to be all real numbers because we can get a 0 here. And that's if x is equal to 2. Then we're going to end up with a 0. So 2 has to be disincluded. Disincluded? That's not a word. But okay. But let's see here. So when we add, the domain is all real numbers. When we divide, when all of these are all real numbers. For the division one, it's all real numbers except 2. Okay? Here's question 2. A ball is dropped from a height of 3 meters. The height of the ball above the ground at time t seconds is represented by the function g of t is equal to negative 9.8 t squared plus 3, where f of t is in meters. If g of t equals 1.5, where g of t is also in meters, what real-world situation can be described by f plus g of t? Okay, so they want to know what kind of situation could explain this. So we have a ball. It's dropped from a height of 3 meters. Okay. And then if we're adding f and g, g is an additional 1.5 meters. What could explain that? So we started at 3, but now we're adding 1.5 meters, so it's moving up here to 4.5. And then the ball's getting dropped. So what could happen to make that happen? This is one that could have multiple correct answers, and there's nothing like this on the end. So don't stress. So it means that the ball is dropped from 4.5 meters instead of 3. So perhaps the person is now standing on a ladder that raised them up 1.5 meters. Okay? That's just one possible answer. Here's practice question, end of the lesson. Given that f of x equals x minus 1 and g of x equals x squared plus 3x minus 6, find f plus g of 2. Okay? So this is a two-step problem. First, you have to take your f of x, which is x plus 1, and you have to, add it to g of x, which is x squared plus 3x minus 6. This is going to give you a new formula. New formula. Then you have to take that new formula and you're going to plug 2 in for every x value and solve. That will give you your answer. Oh, wait, this is a practice. I can do this with you. Ha! I thought this was a quick check. Let's continue. Okay, x times x squared gives us x cubed. X times 3x gives us 3x squared. X times negative 6 gives us negative 6x. 1 times x squared gives us x squared. 1 times 3x gives us 3x. And 1 times negative 6 gives us negative 6. I can't believe I fit that. Now we need to combine like terms. We still have x cubed. Go away. We have 3x squared and x squared, so that's 4x squared. Go away. Go away. We have negative 6x and positive 3x, so that's negative 3x. Go away. Go away. And we have negative 6. Okay, Dad Bob called about the stalkers, so hopefully I remember where we're at. Now we need to solve it for f plus g of 2. So we're going to go 2 cubed plus 4 times 2 squared minus 3 times 2 minus 6. Hey, I'm writing a lot smaller now, although not neater. 2 cubed is 8, plus 2 squared is 4, times 4 is 16. Negative 3 times 2 is negative 6, and another negative 6. 8 plus 16, I should know this, but I'm going to have to count like a child. 16, 17, 18, 19, 20, 21, 22, 23, 24. Yes, I used my fingers. And negative 6 and negative 6 is negative 12. So our final answer is 12. I helped you. Okay, practice question 4. Given that f of x is equal to x squared minus 5x plus 6 and g of x is equal to x minus 2, what value of x must be excluded from the domain of f divided by g of x? Okay, so the first thing we're going to do is write our formula. We have x squared minus 5x plus 6 divided by x minus 2. And what we need to know is what value of x must be excluded, and it's anything that makes this 0, which is going to be x is equal to 2. So 2 has to be excluded. I didn't give you time to answer that on your own. I'm sorry. Practice question number 5. Given that f of x is equal to 3x plus 1 and g of x is equal to 2x minus 5, select the option that gives the correct function f times g of x. I'm going to go ahead and write it out because that's how I roll. I am very, very, very left-brained, and I have to do things neat and orderly even though my house is a disaster. Okay. The reason my house is a disaster is because I'm the only one that cares about neat and orderly in my house. 3x times 2x is 6x squared. Hey, look at that. We already have our answer. Boop, boop, boop. Again, I didn't let you have time to answer on your own. I'm sorry. Quick check question 4. A rectangle has a length represented by the function f of x equals x and a width represented by the function g of x is equal to x plus 3, where both functions are in feet. Calculate f times g of x and state what it represents. So what you're going to do is you're going to take your first formula, which is x, just plain old x, that's f of x, and g of x is x plus 3, and you're going to multiply those together. So you're going to distribute this to both problems. You'll do x times x and x times 3, and that's going to give you your new formula. And then you're going to find your formula down here, and then once you find your formula, you have to find out if it's talking about perimeter, which is just the outline, like if you're doing a fence around something, or if it's talking about the area, which is everything inside of it. And if you don't know the formulas for that, perimeter is equal to a length, it's 2 length plus 2 times width, and area is equal to length times width. Okay, I will just give that to you. Here's quick check question number 5. Given that f of x is equal to 6x squared minus 2x and g of x is equal to 2x, what is the domain of f divided by g of x? So first you'd write your problem, which is 6x squared minus 2x divided by 2x. And then to find the domain, you need to figure out if there are any numbers that would make this part of the problem 0. If there are any x values that would make this 0. And if there are, you need to exclude those numbers, not disinclude. Hey, look, I found the right name. Now, don't look here if you're squeamish, because I warned you that Canva had some graphic photos of poop. And thank you for your attention, although you're probably not very thankful, and I don't blame you.